Let me show you some examples here, worked examples of naming ionic compounds. Suppose you are asked to name this compound. What would be the name of it? Now, I can do this by cutting the molecule or the compound into two, because I see I have a polyatomic ion and I see I have a metal. So really, this two tells me I have two sodiums. And you know, this is ionic compound because you have a metal and non-metal. The metal is sodium, the non-metal is carbon and oxygen. Sodium is a group 1 element. It's right here. It's main group 1, so it's predicted to have a charge of +1. And then this is polyatomic. Polyatomic means it's a group by itself. It's a carbonate. The charge is -2. And if you want to find it, you will find it in our polyatomic list. It's right here. Carbonate, you see it. Okay, I highlighted too much, but it's this one. It has a 2-, something to memorize. Remember, sodium will be 2+, carbonate 2-, so they cancel out. So this one does not have any other charge but plus, so we just call it sodium, and this is carbonate. So the name of this compound is really sodium carbonate. Let's do another one. What if someone gives you a compound like NH4PO4, but this NH4 is going to be having a 3. Now I know that I can break this down again. NH4 is polyatomic for ammonium. So I split it. It seems like we have 3 of them. And then PO4 is polyatomic of phosphate. So you will see the PO4 somewhere in our polyatomic ions here. It's right here. Phosphate. He has a charge of 3-. Again, you can see 3 times 1 is 3+. And then this is 3-. They all cancel out to give you 0. That's the rule for ionic compounds. They have overall charge of 0. So I know that the name of the first part is ammonium. The second part is phosphate. So this is ammonium phosphate. For the third example, suppose you are given K2SO4. Now I know K is monatomic, and it looks like we have 2 of them, and potassium himself is in main group 1, 1A. So I expect it to have a charge of +1, but we have 2 of it in the formula, in the compound. And then we have the polyatomic ion sulfate. You'll ask, how do I know it's polyatomic? Because it's one of the polyatomic ions we learned in class. Sulfate is right here. Okay, this is sulfate right here. I'm circling in black. He has a charge of 2-. And again, you can confirm that is correct, because 2 times 1 is 2+. Sulfate brings 2-. Again, this compound is overall neutral. Potassium is just potassium. We don't call it potassium 1 because only +1 will be the charge of potassium. And then the second part is a sulfate. Okay, so that will be the name, potassium sulfate, for this compound right there, is potassium sulfate. Let's do another one. So suppose someone gave you this one, CaSO3. Now I know Ca is supposed to be in the second group of the periodic table. Calcium is right here. I've shaded in green. Okay, and so since it's in the second group, main group 2A, I expect it to have a charge of 2+. And then SO3 is a polyatomic ion. It's right here. Below the sulfate is right here. It's written as SO3 2-. Just like the sulfate, this one will have 2-. but you can tell he has fewer oxygens. So we call this sulfite, ITE, while this one is ATE. He has maximum 4 oxygens, this one has 3, less 1. This is calcium. Again, calcium does not have any other charge other than 2+. That's normal for group 1, 2, and 3. Main group 1, 2, and 3, they usually maintain only 1 charge, so we don't need to say calcium 2. No. He only exists as calcium 2+, so that's it. So the name is calcium sulfite. Now, what if someone gave you this compound? Okay, iron is one of those metals. Can split it this way. Iron is one of those metals that can exist as 2+ or 3+. We say he has multiple oxidation states, oxidation numbers, 2+ and 3+. Now, to know which of these is in this molecule, we can break it apart. We follow the reverse of how to write the formula. This formula can be written as iron subscript 1, bromine subscript 2. So these two really came from the Fe, and this one, the 1, came from the bromine, meaning we must have had Fe2 plus and 2 Br minuses. So -1. You see this one? We cross it down to the ion. This one, we cross it down to the bromine. Then the formula will be Fe1 Br2. These two came from the +2, that 2. So that's how we know that by working reverse, that's how we know that we are dealing with ion 2. So this will be Fe2 plus. He gave the bromine these 2, and the bromine gave the Fe, the 1. So it will be -1 for bromine. So bromine will be -1. But we have 2 of the bromines and just 1 of the Fe. So 1 of the Fe, 2 of the bromines, to balance out the charges. 2 times -1 is -2. FeBr2 is overall neutral. So we are working with ion 2. And so the final name of this compound will be ion brackets parenthesis 2 and then bromide. This is the systematic name. That's the systematic name. Now, if you want the common name for this, common name will be ferrous bromide. If it was +3, we'll call it ferric bromide, but because he has the lesser charge, it's ferrous bromide. Here you don't specify the Roman numbers, so systematic name is what we mostly ask for. So this is ion 2 bromide. Let's try another one. So suppose example number 6, someone gave you this compound. Now I can split it into 2. I do know that sulfate, the polyatomic ion sulfate, this one, is written as SO2-. So this tells me that the sulfate has a charge of 2-. So what charge should we put on copper in order to kill the 2 negatives? You're right. We need to add 2+. Now copper is one of those that can exist in 2 forms, copper 1 and copper 2. So it looks like you're working with copper 2. So we have to specify that we have copper 2. And then this is just the polyatomic ion sulfate. So the molecule, the compound here is called copper 2 sulfate. We keep going. How about someone gives you that one? Now remember again, copper can exist as copper 1 and copper 2. So we have to specify. We can carry it here. We know we have oxygen. There's an implied one there. So this compound is made from an ion of oxygen. Oxygen is in group 6A, so it's 2 steps to 8A. He has to react by gaining 2 electrons. So oxide. Okay, that's not a polyatomic ion. He's by himself, he's monatomic. So what charge must copper have to neutralize the two minus? The copper here, overall, the two coppers, I should say, you see, you have two coppers. The two coppers must have an overall charge of 2. So that means I just need to put plus 1 there. So that 2 times 1 gives you plus 2. Here you only had 1 copper, but here it says 2. So we have to factor in that we have 2 of them multiplied by a given charge to neutralize the 2 minus. So in other words, you can say 2x plus minus 2 must be equal to 0, because we say that the ionic compound must have an overall neutral or 0 charge. So if you want to find x, it would be 2x minus 2 equals to 0, 2x equals to plus 2 if you add 2 on both sides to get rid of this. And then x will be equal to plus 1, which is this number here. So what this is telling me is telling me that I'm dealing with copper 1. So the name will be copper parenthesis 1 and then oxide. Oxygen with 2 minus, the anion of oxygen is oxide. We learned that in our lecture. Okay. All right. So what if someone gives me example number 8, PbO? Now I can split it here. Pb is one of those that can have a 2 plus or a 4 plus according to our notes. So we have to specify. We need a charge here, we don't know. But oxide, as we said, always has a 2 minus. So what should be the charge here to make sure that overall this thing is neutral? So we can say x plus minus 2 must be equal to neutral, 0. So x equals to 0 plus 2 equals to 2. X equals to 2. So that tells me that my Pb has a 2 plus that combines with the oxide. So the name will be lead. Pb is lead 2 oxide. Now let us answer a different type of question concerning ionic compounds and their formula. We need to write the chemical formula of the compounds below. So the first one that I wrote here is zinc phosphate. Now, if you're asking me to write the formula of zinc phosphate, again, I'll split this to the metal and the anion. You know, the anion can be the nonmetal or polyatomic anion, you know. So we can firstly do that. I know that zinc, by default, zinc is always zinc 2 plus. He never has any other charge. I don't need to use the Roman numerals. Phosphate, on the other hand, from the notes, we know that that one is a polyatomic anion. Okay, and the formula for phosphate is PO4 subscript 4 superscript 3 minus. And you can find him here. There's the phosphate, PO subscript 4 superscript 3 minus. So I'll write the phosphate here like this. Now, that is not the formula of the ionic compound. We need to combine these two ions, the zinc ion and the phosphate ion. Let us bring him here so we can be clear in our process. The process involves dropping the absolute value of these charges, meaning I'm going to drop the 2 below the polyatomic ion, and I'm going to drop the 3 to be a subscript below the zinc. That leads me here. That's going to lead me here. So the zinc will have subscript 3. The phosphate polyatomic ion is going to have the 2. We drop the numbers. They are no longer up here. They are missing. because we dropped them. So this tells me that really for this compound to form, we need 3 zinc 2 pluses and we need 2 phosphates. Okay, those 3, the 3 came from down there, the 2 came from down there. Anyway, that's extra information. Let's give our final answer. So our final answer will be Zn subscript 3 PO4, because it's a group, put parentheses and then put 2. That, my friend, is the answer to this question. That's the chemical formula of zinc phosphate. Okay, number 2, are you able to write the formula of lead 4 chloride? So we begin the process again. The formula for lead is Pb, but because it tells me it's lead 4, that means Pb has a charge of 4. The formula for chloride is Cl, but it's a chlorine in main group 7A. To get to 8A, it needs to gain 1 electron, so it will be a negative. Now you have Cl minus. You see how you have 4 plus. So how many chlorines will you need to neutralize the 4 plus? If you want, you can do the math to determine what number is going to be here, because it looks like we only have 1 Pb. So say 4 plus x times negative 1, because you need to know how many chlorines you have. And this must give you 0 because lead 4 chloride is neutral. So this will be 4 plus minus x equals to 0. So 4 minus x equals to 0. 4 equals to x. So we need 4 chlorines. And that makes sense because if this is plus 4, this has to be minus 4. So now we can conclude from here that we have 1 lead 4 and it's combined to 4 chlorides. Okay. So the formula of this can be taken just as PbCl4 because we need 1 Pb and 4 chlorides. That is one way to do this. The other way, using the method I've been using, dropping the powers, will be Pb4 plus, that's the lead 4, and the chloride, they need to combine. This is negative 1 because chlorine gains 1 electron to be stable. So just drop the absolute number 4, drop the absolute number 1. So 1 goes here, 4 is going to go there. What do we end up with? We end up with Pb1Cl4. We don't need parentheses. Chlorine is not polyatomic. And this can be written implying the 1. So it will be PbCl4. That is the final answer. And you see, is the same as what we got with the first method. I like the second method better because you just drop the powers. That's the answer. Let's try the last example, number 3. Suppose you are asked to write the formula of calcium hydrogen carbonate. Calcium hydrogen carbonate. Hydrogen carbonate is right here. It's a polyatomic anion, so I can split here. I know that calcium is main group 2A element. The symbol for calcium is Ca, so it gets a 2 plus. It loses 2 electrons. It's a metal. Hydrogen carbonate formula is a group of elements which is HCO3 superscript -1. So if I want to quickly find the formula of this, I can drop the absolute value of 2 plus, which is 2, absolute value of -1, which is 1, and simply put the formula here would be Ca subscript 1. Use parentheses for the polyatomic anion. That 3 should be convincingly here below the oxygen, and then the 2 came from the calcium. So the 1 came here, the 2 came from the calcium, and it's there. Now to finish this off, the formula will be Ca, just imply the 1, and then put parentheses, HCO3, and then 2. That is a formula of calcium hydrogen carbonate. And you can practice the process, so on and so on. There are so many practices you can do with this.